Good evening to one and all. Myself, Ensai Pranav from Group G366, and the product that I'm working on is called Finance GPT. Simply, in simple terms, it is nothing but understanding finance through Gen AI models. So, our project mainly revolves around the world of finance, where we try to build a mobile application that can classify financial documents. It can answer questions asked by the user, question answering model, and it can also summarize and mask any important personal information that you want to hide in a financial document, like Aadhaar card number, bank account number, etc. And this is done through and this is the gist of the problem statement. And the technologies that are used are Flutter, which is a tool that is used to build the mobile application, and Firebase is nothing but it's like the database that we use to store data. GenAI is nothing but the multiple AI models that we use, like Llama, Florence GPT for PI masking, and BERT for the question answering model, and Vision Transformer for document classification. Next component is Flutterhooks, which tries to incorporate a React framework our uh, into our application in the environment. And AWS is nothing but the Amazon Web Services, where uh, uh, we can it's nothing but it's a cloud platform which we can use to deploy our model, and store it as well. Next, we enter into the dataset. This is the main crucial part of the whole video, where we try to understand how the dataset actually works. Like so, this is the dataset, which contains pretext, posttext, and table text, and the concatenation of adding all these three will give us the main context for a particular question, where the answer lies in the table text. The question, sorry, this is let's say this is the question. By the way, this whole data is in a JSON format, where pretext and all of them are in key value pairs. Now, this is the question answer, and there are multiple steps, and there's a program. This By following this particular program, we get that this particular answer, exe answer. And this is a refined version of the program, and this is an id which is a unique id for every different question answer pair. And this is how the dataset looks like. This is exactly how the dataset looks like, and there are multiple such objects in the JSON file. Next, we enter into the BERT model. Now a BERT model is trained on this particular dataset. The main aim or goal that we want to achieve is that our model needs to generate a program. It needs to get trained, so that it can generate a program. The program that I'm talking about is this. It needs to generate this particular program that it can execute to give out the answer. So, this is the architecture diagram, where we give the input, and the position encoding takes place. I mean, the tokenization and position encoding takes place. This is the position encoding, where it gets added to the tokenized version, and finally it results into the position input embeddings. Tokenize, I'm sorry, input embeddings plus positional encoding gives out input embeddings, and this is of the size 210 and 256. That is, its embedding dimension is of size 256. It enters a multi attention, and after the query key value operation takes place, we finally get a context enriched output of size 256 again. Basically, size remains the same, and it further enters into feed forward, because that's exactly what's in the architecture diagram. And normalization takes place in order to prevent overfitting, and this is all incorporated in the encoder layer, where all of this where we try to call the feed forward and multi attention classes, and this is the resultant vector of batch size 2, sequence length 10, and embedding dimension being 256. Now, this generated output. Now, let's say we give an input question. I can show you it in the code. This is the input. This is generated program, where we give the input text. Where we give this input text. Let's say I give this input interest rate to a variable. Actually, this is the exact text that is available in here. interest rate or variable interest, it's the same sentence, and that goes into as input text along with we add the post text, table text, and the goal indices as well into this whole sentence. It's a very big sentence, and finally this is the actual program that it is trained with, and it generates a program itself after getting trained in this generator program inference, and the output is in this format. It generates this program, although it is not exactly accurate, but this is the program that it generates. Basically, is getting trained with is getting trained on this data set, which it tries to generate a program, so that in the future when the user asks a question, it can perform this particular program and give us the answer. So that is basically the output of our BERT model, and it is used by the end users can be financial analysts or any seasoned professionals, etc., and large tech companies as well, to name a few end users. And so this is the project in its entirety, and yeah, thank you.